Hello. Hello, I'm Harish Kanaya from Kyushu University. Can you hear me?
Hello, Professor Kanaya.
Hi.
How are you?
How are you? Great.
You can start sharing your slides to double check that slides is okay.
Yes, I want to check this.
We will start in 15 minutes, so we have 15 minutes for experiments.
Okay, so 15 minutes. Yes. How are you?
Is there any problem?
Sorry, Okay, 50 minutes. Waiting this time. So can I share this one?
في ايه اللي حصل مالك دينا الصبح كده اي حاجه ليه؟ لقيت انت قدمت ورق؟ انت دلوقتي ايه؟
نعم. روم 1 ما مكتوب في البروجرام روم 1. Professor Kanaya?
Yes.
Sharing. في آخر صفحة هتلاقي بروجرام ورا بعض.
Yes, I'm Harish Kanaya.
I think you can share your screen now.
Okay, I will share this one.
Okay. Okay, we can see it now.
Can you show the main slide?
Yes, but we are seeing your comments.
Okay.
You have to change the method of sharing. Yes, okay. That's fine. Much better.
Thank you very much. Thank you.
Thank you. Now to make things more clear, I will just return back to attendee for this time being. When the session will start, I will promote you again to panelist. Okay?
Okay.
Professor Kanai?
Yes.
I will stop the sharing for you. I will stop your ability to share, and I will mute you for the beginning or for the opening session. When the session 1 will start, I will just promote you to the panelist again. Is it fine? Oh.
Yes, okay.
Thank you.
Thank you.
كام attendee 23. صباح الخير دكتور احمد.
صباح الخير. صباح الخير. عرفت الوزير جاي امتى؟
هو مكتب الوزير دخل معانا حضرتك وشيكوا الكونكشن.
طيب كويس. هنبدأ امتى؟
هو المفروض ان لما سيادته يوصل، يعني المفروض الساعة 10، ميعادنا الساعة 10.
وترتيب الكلمات؟
أول كلمة ليا كتشير، وبعدين بروفيسور كوجي ككوتشير من كيوشو، وبعدين دكتور أحمد حسن اي تريبل اي تشير في ايجيبت، وبعدين بروفيسور جوتو، وبعدين حضرتك، وبعدين الوزير.
طيب.
دكتورة مها هي اللي هتقدم المتحدثين يعني.
ماشي. وجوته دخل؟
لحد دلوقتي لا، بس هنشيك عليه حضرتك. انا بعت لهم ريمايندر تاني. دكتور احمد دخل، دكتور احمد حسن دخل. نعم.
كانوا بيقولوا ان هناك بس مش سامعين.
لا جبنا سماعات التلفزيون فيها سماعات اصلا.
اتفضل يا دكتور سامح. اتفضل.
لا ما هو موجود، احنا شغالين ده وفتحوا لنا لا ماليش كلمه بس مش احنا جبنا نجهز حاجه ايه مشكله كل حاجه هنبقى نحط ساعات بالظبط. الله يعين.
ابو زهاد اعملوا الدنيا ميوت لحد ما تجهزوا.
دكتور رامي سامعني كويس كده؟
صباح الخير يا دكتور أحمد. صباح الخير يا دكتور محمد.
دكتور احمد ازاي الصح؟ اخبارك ايه؟
Good morning, everyone. Thank you for joining us. We are just waiting for His Excellency, Ministry of Higher Education, to join us to start the conference. Thank you for your waiting.
دكتور احمد صباح الخير.
شكرا يا فندم، ده الصح. متشكرين على وقت حضرتك.
تحياتي لحضراتكم كلكم. انا بعتذر عن تاخير ان كنا في اجتماع مع رئيس الوزراء بس.
لا ابدا. نستأذن حضرتك نبدأ؟
اتفضل يا فندم.
دكتورة أبو زهاد، دكتورة مها. دكتورة مها.
صباح الخير. Good morning, everyone. My name is Professor Malsa Bhuti from Egypt-Japan University of Science and Technology, and on behalf of the organizing committee of the 2020 International Japan-Africa Conference on Electronics, Communication, and Computing, I would like to welcome you to the opening session. The conference runs in its 8th edition, and we go through, for the first time, through a new experience due to the COVID-19, where we held the conference virtually online. Nevertheless, the conference has not lost a beat. We still got decent number of quality papers that have been submitted to the conference, and the usual activity of the workshops are running as usual. As the conference acted as a bridge between Japan and Africa and Egypt in academia and industry, the conference enjoys a strong support from Japan and from Japanese partner in Kyushu University and Egypt side. We began the conference by the word of the conference chair, Professor Mohammed Abu Zahed, Dean of the School of Electronics, Communications and Computers in Egypt-Japan University of Science and Technology.
Bismillah ar-Rahman ar-Rahim. Dear His Excellency Professor Khalid Abdel Ghaffar, Minister of Higher Education and Scientific Research, dear Professor Ahmed Johari, E-Just President, dear Vice Presidents, dear Professors, authors, and colleagues. On behalf of the organizing committee of the International Japan-Africa Conference on Electronics, Communication, and Computations, JAC-ECC 2020, in its 8th run, I am honored and pleased to welcome you all for attending the activities of the conference. Held online at Egypt-Japan University of Science and Technology, E-Just. I would like to take this opportunity to thank His Excellency Professor Khalid Abdel Ghaffar, Minister of Higher Education and Scientific Research, for his patronage of the conference jointly organized between Egypt-Japan University and Kyushu University. In fact, the conference could not have been realized without the strong support of E-Just leadership. Professor Ahmed Johari, the president of the university, gave the conference a lot of time and guidance to have it realized at this professional level. This year, as many other conferences have already done, we decided to hold the conference virtually, and I would like to thank our keynotes, workshop presenters, authors, for their patience and understanding during this time of transition to virtual conferences. As in our tradition, together with our Japanese partners, we put together a solid technical program. I would like to start by thanking our keynote speakers for their valuable contributions, namely Professor Harushi Kanaya, Kyushu University, Japan, Professor Ahmed Al-Wakil, University of Sharjah, United Arab Emirates, Professor Magdi Saib, Arab Academy of Science and Technology, and Professor Mahmoud Abdallah, Technical Military College, Egypt. This year, we received 38 publications in 8 technical tracks from Egypt, Japan, New Zealand, China, and accepted 21 publications with an acceptance rate of 55%. I would like to thank our TBC from Egypt, Japan, Australia, Canada, New Zealand, Kuwait, and Saudi Arabia who worked hard and performed 123 reviews. In addition, JAC-ECC 2020 will hold a workshop on the topic of next generation wireless networks for smart cities, with contributions from Egypt and Japan. I take this chance to thank the workshop speakers, namely Professor Salamigo Yu, the University of Electronic Communications, Japan, and Professor Ahmed Khattab, Cairo University, for sharing the latest development in this fast evolving field. An important addition to this year's conference, in line with 2030 Egypt Strategic Plan, we are hosting a talk titled Digital Egypt Builder Initiative, DIBI. Dr. Huda Baraka, the advisor of the Minister of Communication and Information Technology for Technology Talents Development, will present this talk. The initiative of this talk has been initiated by Professor Ahmed Hassan, the Dean of Faculty of Information Technology and Computer Science, Nile University, and IEEE Egypt Section Chair. This year's conference organization was unique, different, and challenging, and I thank the organization committee members from Egypt and Japan for their tireless efforts to hold the conference. In particular, I would like to thank Professor Koji Unai, the conference co-chair, Professor Osama Muta, the organizing committee co-chair, and their colleagues from Kyushu University. Recognition should go also to the local organization committee co-chairs, especially Dr. Ahmed Allam, Dr. Ahmed Abdel Malik, Dr. Samir Al-Saghir, and Dr. Ramiz Wil, who have all worked extremely hard over the past year to assure that the conference, with its unique activities, will be a landmark event. Finally, I thank our sponsors, Ministry of Higher Education and Scientific Research, MUHI, IEEE Egypt, IEEE VUCOCA, IEICE Communication Society, eJust, and eJust Center at Kyushu University. In addition, I take this chance to thank STDF for the financial support of this year's conference. Once again, thank you all for your participation, and welcome to Egypt and welcome to eJust. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Thank you very much, Professor Abu Zahed. And as the conference chair has pointed out, this conference is a joint event between Egypt and Japan, and more particularly between Egypt-Japan University and the University of Kyushu University in Japan. And as such, I would like to invite Professor Koji Inoue from Kyushu University, the conference co-chair, to give his word.
Okay, so can you hear me? Okay, thank you very much. Thank you. I'm Koji from Kyushu University, and I'm the director of the eJust Center. So I'm very happy to serve as a co-chair of this conference with Professor Mohammed Abu Zahed. So as you know, this is fully virtual conference, but really this is high quality, and also we can really enjoy that conference. So the success of this JAC-ECC would not have been materialized without the great support of many people. First of all, I'd like to thank the conference attendees and researchers, students who submitted their papers. Maybe some papers are accepted, but some papers for some students are not accepted, but please join and enjoy conference. And also, second, I greatly appreciate the technical committee organizing members and also co-chairs or organizing committees. So I must also give thanks to all TPC members. So they spent a lot of their time for paper selection. So furthermore, I'd like to thank all organizing members. So I really appreciate all relevant staff at eJust and Kyushu University for supporting this conference. their significant contributions will make this virtual conference a success. And we are also grateful to the JICA-ECC project, technical sponsors, IEEE Egypt section, and also IEEE Fukuoka section. And finally, we also would like to give my special thanks to MOHI. Without their strong support, our ECC project could not get such big success. And the last, so under the significant leadership of Professor Gohari, so ECC project is very, very, very going well, I believe. And I think some guys knows where it is. So this is my favorite, one of my favorite photo in Egypt. So maybe next time I can be back there. And also this year, virtually, I am with you. Thank you very much.
Very much, Professor Koji. And actually, it's the main downside of holding this conference virtually is just missing the colleagues in Japan, their physical presence here in Egypt. We miss you, and we hope next time you will be here physically. Thank you very much. And as you have mentioned, and as the Professor had mentioned, the conference has many sponsors and many endorsers. Among them is IEEE Egypt section and IEEE Fukuoka section. And it has been endorsed by the IEEE for a very long time, since its inauguration 8 years ago. And the papers are actually published on IEEE Explorer as one of the elite conferences. Few conferences in Egypt are enjoying this characteristic. So I would like to invite Professor Ahmed Hassan, the Dean of Information Technology and Computer Science at Nile University, and the President of the IEEE Egypt section, to give his word.
Thank you, Dr. Maha. I will show you a very small presentation. I will not exceed the 5 minutes assigned to me by Dr. Abu Zahad. I will just share with you some information about IEEE Egypt section. I hope you can see the presentation right now. This is the IEEE at a glance. These numbers represent IEEE globally, where we have more than 400,000 members in nearly all the world. And we have a lot of student branches at universities, more than 3,000 student branches. But I'm very delighted to say that we have now a student branch in Egypt Japan University for Science and Technology. And I think this student branch will make a lot of activities for students and graduate students in Egypt and Japan. Egypt story with IEEE was a long story. We are the oldest government in the world history. We had the second rail road in the world, and we are proud that we are the second IEEE section in Region 8. Region 8 is Europe, Middle East, and Africa. And we are proud that we had this history, and we had a lot of giants who led the section during the interval from 1955. We are celebrating now 65 years of IEEE Egypt section. The founder was Dr. Hammam Mahmoud, and as I told you, we were the second section outside USA, and we have a lot of technical societies and councils. We have a lot of student branches, and we have 3 affinity groups, one for the young professional, one for women in engineering, and one for the senior members, or what we called life members. We have established the new chapters this year. Examples include Circuits and System, Photonics, and System Council. And we have very vibrant leadership and changes. So I would like to congratulate Dr. Hani Hassanin for being selected as the Power and Energy Chapter Chair, and Dr. Nafa for being the Communication Chair. And I would like to say that Alexandria subsection will have a change in leadership this year as well, and the power electronics chapter. So anybody who is interested to participate as a volunteer in one of these positions, he is very welcomed, or she is very welcomed. We are here in Egypt since 1955, and I'm delighted to say that we have got the outstanding section membership retention performance over Region 8. It's the silver medal there. And I would like to say that we have many conferences this month. For example, there is one in the Arab Academy of Science Technology just finished yesterday, and we have JAC-ECC, and we have another one in Ain Shams tomorrow, and the last one will be in Cairo University in 29th of this month. And we had other conferences this year as well. All of them, as Dr. Maha said, all of them are published on IEEE Explorer. I would like just to share with you that Dr. Tariq Abdel Mohsen, who was the founder of MEPCON this year, has passed away, and I would like to just give you some information about the mission and vision of IEEE. It's good to refer to the IEEE website to get the mission and vision and ensure that we are aligned with this mission and vision. And we are celebrating our core values and use them wisely for the advancing of technology for humanity. I would like also to highlight the importance of women in engineering and encourage eJust student branch to have a section for women in engineering. Women is making a lot of difference in engineering, and they made a lot of difference to encourage young students in the schools to have engineering as a profession in their future. They change the world because they are. Also, I would like to encourage all of you to have the IEEE application on your phones. It will give you information about the technical sessions and conferences that are existing this month and in the coming month as well. And I think being virtual is good for us because we can have a conference in Japan right now, and we have a conference session after 3 hours in USA. So it's good for us to get information from every part of the world. We have a lot of activities that are usually done under the patronage of Dr. Khalid Abdel Ghaffar, including the Egyptian Engineering Day and Made in Egypt competition, NASA Space Apps, and Future City. But this is canceled this year because of the large number of students who cannot be gathered in one place, even with all cautions and all precautions. I would like to say that our life members made a lot of guidance for the entire Egyptian society in engineering, and our young members, I would like to thank them for their activities. These are just some photos from the different activities done in Egypt, which we are proud of. I'm here for any question. Thank you all, and I hope you enjoy a very fruitful conference as usual. Thank you, and thank you, Dr. Abu Zahed. Thank you, Dr. Gohari. Thank you, Dr. Khalid.
Thank you very much, Professor Ahmed Hassan. And as Professor Ahmed Hassan has just said, like Egypt is actually having a plethora of international conferences. We talked about like the vertical axe, which is like the conferences that are held in the dimension of electrical engineering. However, in Egypt here, we have a lot of conferences. Egypt, the JAC-ECC is the oldest one of them, and they are all getting the support from Egypt's side, and the support of the particular conferences are supported by the Vice President of Research, Professor Gotu. So I would like to invite him to give his word.
Okay, this is Goto speaking. Can you listen to me? Okay. Can you hear? Can you hear?
Yes, we can. We can hear
Yes,
you.
Oh?
yes.
Yes.
Okay, okay, thank you. Okay, this is This is Goto, Vice President of the EJUST. I'm also the members of the IEEE and IICE for a long time, almost 50 years. And now I'm on the IEEE Life Fellow and IICE Fellow. Okay, I'm working for those societies. This is eighth run of the conference, and I'm very glad that the conference grew to be well aligned with the EJUST mandates. The gathering of the distinguished scholars exemplifies a core strategy of EJUST to act as a bridge linking university and scholars in Egypt and Japan. I take this chance to welcome the distinguished guests from the Institute of the Electronics, Information, Communication Engineers, IEICE. It's the largest society of ICT professionals in Japan. We at EJUST are honored to have hosted the IICE event in Egypt, in JAC-ECC. And now this is the fourth time, I guess, to host the IICC supported event in Egypt. I would like to thank the organization and the technical committees from Egypt and Japan, led by the Professor Abzahat, ECE School Dean, and Professor Koji Inoue from the EJUST partner Kyushu University. And I have to say that we have a remarkable cooperation with Kyushu University. Together, we had many accomplishments. We started the first PhD degree program, and that was granted by Japanese Higher Institute in Egypt, African, and the Middle Eastern. And the Kyushu University hosted more than 40 students, over PhD students so far during their stay in Japan. So scholars co-supervise our graduate student research work, and we look forward to continue and increase this successful collaboration. ECC stands for the Electronic Communication and Computers. Those have been advanced drastically in these years. As you know, in electronic, high-speed device with ultra-low electric power come out. And IoT, Internet of Things, is becoming popular and surrounding us. In communication, 5G with gigabit speed and low latency has been developed and almost in use. In computer, artificial intelligence now came back with deep learning technology and now contribute to the real applications. I personally have been working in this area for more than 50 years since my student days in university in Japan, and also the researchers in industry. I felt this moment is the most exciting time and most competitive the world. I think that every student and researcher here really enjoy this amazing time. I would like to say that IICE, I just mentioned, will publish special issue on Egypt, science and technology next April. That's a very nice, good news. And I'm editing this, all the papers and journals publications. I'm looking forward to having much closer collaboration and cooperation between Egypt and Japan. I hope that all the attendants here will enjoy the conference and got something new from this JAC-ECC, even by the virtual way. Wishing all attendants a beneficial conference. Welcome, everybody. Thank you.
Thank you very much, Professor Gudu. And as you mentioned, JAC-ECC is actually achieving the main goals of Aegis University, which is the joint collaboration between Egypt and Japan. Aegis has supported the conference in all its 8 runs till now, and it's for the 3rd time it's held in Egypt premises with direct sponsorship from Egypt Japan University of Science and Technology and Aegis President Professor Ahmed Al-Gohari, who graciously granted the conference access to the rooms, to the theater, and to the different Aegis facilities, and the endless help of our colleagues from the administrative staff. We would like to invite Professor Ahmed Al-Gohari, President of Egypt Japan University of Science and Technology, to give his word.
Good morning. Thank you, Dr. Maha, for the introduction. Your Excellency, Professor Khalid Abdel Ghaffar, Ministry of Higher Education and Scientific Research, dear distinguished guests, friends, and colleagues, on behalf of Aegis Management, I welcome you all to the virtual International Japan-Africa Conference in Electronic Communication and Computations, JAC-ECC 2020. This gathering of distinguished scholars is the core strategy of Aegis to act as a bridge linking universities and scholars in Egypt, Africa, and Japan. We are very proud with the trust boosted to Aegis and JAC-ECC as the conference is held under the auspice of His Excellency, Minister of Higher Education and Scientific Research, Professor Khalid Abdel Ghaffar, and the contribution of the Ministry of Communication and Information Technology through the dissemination of Presidency initiative titled Digital Energy Egypt Bidders and the Initiative, acronym DIPI, that has been announced by His Excellency Minister Talat during the visit of His Excellency President Sisi during the opening of Aegis new campus on 16th of September 2020, 1 month and more ago. This year, events has been challenging to all of us, and I'm taking this opportunity to thank the conference organizers from Egypt and Japan, led by my colleague and friend, Professor Abu Zahad, ECC School Dean, and our friends, Professor Koji Uno, Aegis, Director of Aegis Center at Kyushu University, for their persisting to hold the conference, the spirit of overcoming difficulties, and insisting on moving forward despite any hurdles, and the will to excel and to contribute to succeed are the traits that distinguish Aegis, and we are thanking for them for their efforts. The conference built on solid history and is gradually becoming a tradition, bringing together every year scholars from Egypt, Japan, and some African countries and worldwide. At Aegis, we have several graduate students from Africa, supported by scholarships granted from the Egyptian and Japanese governments and industry. The conference is an added opportunity for them to get exposed to the latest in the fast developing ICT field. I wish you all a very successful and beneficial scientific gathering and the enjoyable time that will build the strong ties between Egypt and Japan and worldwide. Thank you very much.
Thank you very much, Professor Ahmed Al-Gohari. And as we've just said, the conference enjoys the support of Egypt Japan University of Science and Technology, and also a kind of sponsorship from the STDF side. And as such, all the arrows point to the Ministry of Higher Education and Scientific Research, which we have been enjoying 8 years of patronage from the MOHI side. And for the first time, and we consider it actually as the highlight of the conference, is that we are having the honor of the presence of Professor Khaled Abdel Ghaffar, the Minister of Higher Education and Scientific Research, to participate in this conference. We would like to hear from him his word. Thank you.
Thank you, Dr. Maha. Professor Ahmed Al-Gohari, EJUST President, Professor Muhammad Abu Zahad, the Chairman of the conference, Deans, Professors, colleagues, ladies and gentlemen, allow me at the beginning to congratulate EJUST President and the conference chair from the Egyptian and the Japanese side on their insistence to hold the conference despite the challenges caused by the COVID-19 pandemic. It was also glad to know that this is the 8th time this conference is co-organized between the Egyptian and the Japanese scholars, and that every year you have research contributions from the whole world. I congratulate you for this consistency and for the teamwork. And I encourage you, as modeled by the EJUST and the collaborating universities from Japan, to keep growing hand in hand and to continue to link researchers in Egypt, Japan, Africa, and around the globe. Going through the conference program, I noticed at the beginning many sponsors, and I have to thank them all. On top of them, the EJUST and Kyushu University, and also IEEE Egypt section and IEEE Fukuoka section, together with the STDF and other partners from Japan. This is very important collaboration. And I also noticed that EJUST wasted no time to participate in the Digital Egypt Builders Initiative announced by His Excellency President Abdel Fattah al-Sisi during the opening of the EJUST new campus. The initiative is part of the Egyptian human development and hence a part of Egypt Vision 2030. I was impressed by the effort of the EJUST to introduce this new program in the area of the ICT to enrich the collaboration with this initiative in different fields, such as Internet of Things, data engineering, and cyber physical security. Also, it was very important to set the first conference program track which is artificial intelligence and its topic like deep learning and natural language processing. You may know that Egypt's ranking in the General Government Artificial Intelligence Readiness Index has advanced 55 ranks to be 56 in the world among 172 countries, compared to 111 among 194 countries in the year 2019. According to the report on the Government Readiness for Artificial Intelligence Index issued by Oxford Insights and the Center for International Development Research. According to the report, a methodology for measuring the readiness of governments to use artificial intelligence technique has been applied based on 3 main pillars and 33 indicators, the most prominent of which are the existence of a national strategy for artificial intelligence, data protection and privacy laws, and the use of information and communication technology together with the digital services, communication infrastructure, and the ability of digital skills and the entrepreneurship development culture. Another contribution of this elite conference is the workshop entitled Next Generation Wireless Network in Smart Cities. And I would like to point out that Egypt is currently going through tremendous infrastructure development, including ICT technologies, by building new smart cities, such as the new administrative capitals and others, which will embody the concept of the real smart city. These directions are well aligned with the Ministry of Higher Education and Scientific Research reform initiatives. We have been pushing hard to establish partnership between Egyptian universities and leading international universities and research centers worldwide. Our main intention is to promote the higher education to enhance Egypt's position on the map of the academic as well as the scientific excellence regionally and internationally. You all witnessed the inauguration of our new campus of EJUST, as well as new universities in El Galala, King Salman, Alamein, and New Mansoura. And we are communicating with Egyptian professors, scientists, and scholars from all over the world to encourage them to contribute their expertise and knowledge to revitalize the role of these new universities in Egypt. We are continuously pushing for development in the higher education and scientific research sector in Egypt and calling for participation in the advancement of this sector. Finally, wishing all attendees a successful and beneficial conference. Particularly, I wish the conference organizers a continuous growth and success in linking Egypt, Japan, and Africa. And thank you all for your attention.
Thank you very much, Your Excellency, Professor Khaled Abdel Ghaffar. We thank you for your participation, and by your word, we sum the opening session for the conference, and we directly move to the session number 1, the keynote speaker session, Radio Wave Energy Harvesting Circuit and its Medical Applications. The chairs are Professor Koji Inouye, Kyushu University from Japan side, and Professor Ahmed Ragab El-Biali, Cairo University, Professor Adel Bidair from Egypt side, and the keynote speech is Professor Harushu Kanaya from Kyushu University, Japan. The Zoom link is indicated in the program agenda. So actually, if you can actually participate with us on this session, we would be highly welcome you. Thank you very much.
Thank you very much, Professor. Can you hear me?
Yes, we can hear you.
Okay, so I'm Harushi Kanaya from Kyushu University. First of all, I'd like to sincere thanks to the conference co-chair, Professor Zahar in Egyptian side. Yes.
Excuse me?
Yes.
Can we wait for 2 minutes, please? Just
okay.
Adjusting.
Okay.
Professor Kanaya, sorry for interrupting you. So you can start the presentation now.
Okay, thank you. Okay, so first of all, I'd like to sincere thanks to the Professor Zahar and also the conference chairs and also the organizing chairs, Professor Maha in Egyptian side, and also the conference and TPC members in Japanese side. Okay, so the title of my presentation is the radio wave energy harvesting circuit and its medical applications. So here is collaborating researchers. The Dr. Maso is the PhD fellow in my laboratories, and also he's joined in the Electrical Research Institute in Egypt. And also there are some collaborators in my students, and also the medical doctor in Kyushu University Hospital, and other is for the companies, engineers. Okay, here is the outline of my presentation. First of all, I'd like to show the introduction and what is energy harvesting. And next, I will show you the design and fabrication and measurement of the energy harvesting systems, and also the IoT devices. And following the application to the medical and implant systems. And finally, I will conclude my talk. Okay. So as you know, there are a lot of IoT devices, sensors, and mobile. Yes. Are there any troubles? Okay. So continue my presentation. Okay. So
Sorry,
there are many devices.
Sorry,
Okay.
Professor. The mic was open. I will close it now. Sorry.
Okay. And so the electrical energy is a main problem in the future, the IoT eras. So the numerous unused energy sources are in the ambient world. For example, the vibrations and motions like wind turbine and the solar cell, and also another one is for the radio wireless energies by using the telecommunication system. So here is publication in IEEE magazines. So here, so the RF source is like this, show us to the environmental monitoring, the logistics, and also IoT. So for the environmental systems, the battery is also serious problem. So for the sensor or IoT platform, there are mainly the three layers. One is power layer, sensor layer, and data transmission layer. So in the power layer, there are three sub-layers. One is a power generation layer. Another one is generate or obtain the energy from the electric or the ambient. And the obtained energy are stored in the capacitor. And so their energy is quite limited. So we have to need a power management by using the microcontroller. And for the sensor layer, there are many sensors, and the user can choose the sensors. And for the data transmission layer, there are many telecommunication systems like Bluetooth, Wi-Fi, Zigbee, low power wide areas, and yes, like this. And the users can choose the frequency and also the communication system. For the sensor and data transmission layer, we have to need at least the 2 volt DC supply voltage. So we have to obtain at least the DC 2 volt electric power from the ambient. So from the RF means a radio wireless frequency. And to the DC conversion system, there are mainly two portions. One is wireless power transfer, WPT. That one is already commercially used. For example, the power charging to the for the smartphone, and also the vehicles can be recharged by the WPT system. So for the WPT case, the high RF to DC efficiency. However, the high efficient, the power amplifier, beamforming, and high gain antenna should be needed. And so we have to need the electric power. On the other hand, energy harvesting or energy harvester, EH, has a clean and no emissions. On the other hand, the limited amount of RF power from the wireless communication system, and that one is strictly limited from the regulation. Therefore, the degradation by the parasitic element in the device. So that the efficiency is quite quite low. So we have to obtain the new architecture of the RF energy harvesting circuit. And the target, our target is power supply for the sensors or IoT devices, like microwatt to the milliwatt. And at least 2 volt DC voltage for wake up the circuit. And we have to need a license-free band, like 900 megahertz. This figure shows the block diagram of the proposed energy harvesting circuit. The antennas are attached on the circuit. And in the booster circuit, there are 2 devices. One is resonant circuit, and another is for the rectifier circuit, like a Cockcroft-Walton circuit. So because of the time limitations, I will skip the antenna design. And today I focused on the booster circuit here. There are 2 parts. At first, I'll show you about the resonant circuit. Here is the circuit model of the L, C, and R series resonant circuit, RCL. So here is RF receiving signal. The current in the inductor is like this here. And at the resonance condition, the current can be calculated by this, the E divided by RS. So finally, the output of the voltage at the inductor has Q times as large as input voltage. Where Q means inductance divided by the resistance. So if the resistance is quite small and inductance is quite high, in that case, our obtained DC voltage is the Q times higher than the input voltage. And next is rectifying circuit. Here is the RF signals. So input voltage reached to the negative peak. The blue lines is the current is like this, and charge the C1, capacitor 1. And next positive peak the current goes through like this. In this case, in the C2, we can obtain the C1 plus C2. Therefore, the output voltage is double. So we can multiply this circuit. The voltage can be increasing. Here is first proposed circuit for the energy harvester. The antenna has real impedance or the resistance here. And here is a resonance circuit with the impedance matching circuit here. And here is Cockcroft worked on circuit. And the other one is a 3-stage. So we can obtain the input voltage and output of the resonance circuit and the V out. Here is the time variations of the voltage. Red one is the input voltage. The other one is the antenna receiving voltage. And blue one is output of the resonance circuit. So we can see at least 10 times as high as the input voltage. And the V out, the other one is rectifying circuit, is about 2 volt and almost the flat voltage. That means we can obtain the DC voltage from the RF, the voltage. So this figure shows efficiency by changing the output resistance. Here is output resistance, and here is efficiency. In the low resistance values, the efficiency is also low because the current is high. At the high resonance load resistance regions, we can obtain at least the 60% efficiency. This figure shows the photograph of the proposed circuit. This is first one for in our laboratory. This is our RF input that is connected to the antenna, and here is DC output. This figure shows the frequency response of the output voltage of a proposed circuit. The horizontal line is frequency, and vertical line is output voltage. The blue one shows the simulated the output voltage, and red one is measured the output voltage, and also here the black one is the simulations compared with parasitic components. So as we can see, in the real devices, the voltage will be dropped like 0.4 volt. And the concern by attaching the parasitic elements, the measured results are fit to the simulations like this. This is a comparison of the measured efficiency of the energy harvesting circuit. The frequency is about around UHF, like 900 or something. So in this work, the frequency is 900 megahertz at the simulations. However, in the measurement, there are some parasitics, the frequency decreasing 70 megahertz. And input power is minus 10 dBm, and efficiency is about the simulation is about 58%, and measure is about the 44% with the parasitic elements. However, we can obtain the DC voltage from the RF signals, which is communication, telecommunication systems. Okay, next. So we have to enhance the communication distance or enhance the sensitivity for receiving power. Because as you know, there is a strict regulation. The receiving power is quite low. Here is a planar antenna layout. The other one is designed by Dr. Mansur. And here, the orange is a metal, and gray is a PCB circuit board. And here is the input port. There are two antennas. One is like a dipole antenna, and another is like loop antenna. And here is input impedance matching circuit. This figure shows the layout of the booster circuit. The pale one is metal, and gray is a circuit board. And here is the impedance matching circuit. And there are three types, three sets of the rectifiers. And each rectifier has 8 unit cells. Here is a unit cell like this here. And there are 8 stages. And the green is set 1 and set 2 and also set 3. And here is input impedance matching circuit, and antenna is connected to this and this. So here is a block diagram of the field test. The signal generators can generate the RF signals and through the antenna. And the distance from the antenna to our energy harvesters is from 5 to 10 meters. And the receiving and the RF to DC exchange voltage are stored in the capacitor. And also the power management IC and sensor and Bluetooth modules are connected. The temperature and humidity data are translated to the personal computer and or the smartphone. The communication, data transmission and communications about the Bluetooth low energy system. Here is a photograph of the experimental setup. Here is a receiver port. The antenna is here, and energy harvesters is here like this. And the distance between the antenna to our energy harvesters is 7 meters. And the frequency is 900 megahertz. That one is license-free band. And here is a power management IC. So we can change the interval from the 2 seconds to the 10 minutes. And here is temperature and humidity sensor. Here is a sensor, and also here is a Bluetooth module, like this. Okay, I will show you the measured results. Here is time dependence of the voltage charging to the capacitor. Here is the time, and here is voltage, DC voltage. We can inject the RF signals, and about 7 and 8 minutes after, we can obtain more than 2 volt. The capacitor's output voltage reached to the 2 volt. The sensor and BLE systems can automatically work. Here is the time, and here is the big capacitor. Yes, here. So for the data transmission, the voltage are a little dropped, and to the 300 second, the voltage up, and also in the peak point, the data translate to the personal computer. So here is the voltage almost more than 2 volt. And DC voltage quite stability here. And this here shows the photograph for measuring the body surface temperature. Here is a proposed energy harvester, and power management ICs here, and also here. The sensors are attached on the body surface. So this one is also the BLE unit are inside. So the temperature data are obtained by smartphone or the laptop here. And this here shows the measure results. The horizontal is the time, and vertical is the temperature. Before attaching the sensor on the body surface, we can obtain the room temperature, maybe 22 or 23 degrees Celsius. And after putting the sensor on the body surface, the temperatures reach to the more than 30 degrees Celsius. And these temperatures are the keep when the RF signals are turned off. So we can obtain the energy harvesting circuit, and also we can obtain the suitable output voltage. Next, I will show you the medical application by using our proposed energy harvesting circuit. So here is the current status of the implants. So there are some implants like capsule and scope, and pacemaker, and also the chargers here. So as we can see, the batteries, the number 6, is about the more than 50% of the 4 devices. And so the batteries, battery replacement should be needed. And here is another implant. This is a clear implant, and here is artificial retina like this. So in this case, here is electromagnetic induction method. So in this case, the transmitters are close to the body surface. And for the artificial retina case, we have to need like glass or the surface, the batteries on the surface here. So another application is about endoscopic surgery. The endoscopic surgery is like this. During the operation, the doctors can check the monitors, and there are some cameras and other devices on the body surface. So before the surgical operation, we have to find the tumor by using the endoscopy here. Like this. Here is digestive tract, and endoscopy showed the inside the digestive tract here. So if the doctor find tumors like this, he attached the endoscopic clip like this here. The other one is made by metal, and the size is about, diameter is 2 millimeter. And close to the tumors, there is some metal clip like this. So for the operation, the metal clip can find the X-ray images like this. So during the operation, there are two monitors. One is X-ray image. The other one is showing the inside of the digestive tract. And another is camera, the monitors. The other one is outside of the digestive tract by using the laparoscopic images. So in this case, there is a large X-ray generator and also the protective clothes. The other one is quite heavy, more than 3 or 5 kilograms. And also, it's quite difficult because the doctor checked the X-ray images and laparoscopic image simultaneously. And most important, the important things is exposure to the X-ray radiation. So for the motivation is the position identification without the X-ray radiation. So we will develop the small size LED clip. So in this case, we have to need the power supply inside to generate inside the body.
Please, Professor Kanaya.
Yes.
Can you try to finish your presentation within 5 minutes, please?
Okay.
Thank you.
No problem. Here is, but for the, if the radiation is only one positions, in this case, the electromagnetic fields cannot reach to the inside the body. Therefore, it's difficult to the normal WPT system. So in our new concept, there are called the sandwich, the measurement, sandwich systems. In this case, the RF signals go through the bottom. And this one is quite fit to the electrical scalpel here. The other one is quite closed circuit like this. And the other one is almost the same as our new concept here. So we can design this type of the small size, the energy harvesting circuit. The size is 2 millimeter and 18 millimeter square. And there are two the LED on the PCB. This here shows measurement setup. So here is our proposed the small size energy harvesting circuit. That one is equipped on the stomach wall. And here is lightning test. So we can succeed the quite small size energy harvesting circuit. That application is implant. And these systems are already submit to the patents like this. Okay, so now I will conclude my talk. We can obtain the RF to DC energy harvesting circuit. And also our circuit can work the sensors and BLE telecommunication devices. And also we can obtain the medical application and demonstration. So thanks to the foundation. And also there are collaborators. One is local government, the hospital, and companies like this, and also the other worldwide university. Okay, thank you for your kind attention. Thank you very much.
Thank you, Professor Kanaya, for this interesting presentation. I would like to introduce the chairs of this session, Professor Koji Inouye from Kyushu University and Professor Ahmed Ragab from Cairo University, and myself, Professor Adel Bidir from EJUST University. I want to mention few words about Professor Kanaya. Professor Kanaya is currently a professor in Department of Electronics, Kyushu University, and he is a professor in System Large-Scale Integration Research Center and Vice Director in EJUST Center, Kyushu University. Professor Kanaya is a well-known person. He is a senior member in IEEE USA and IEICE Japan. He has more than 200 papers in various impacted journals and international conference. And now the session is opened for discussion. I received few or some questions from Professor Koji and Professor Ahmed, if you would like to add something or to ask some questions, please.
I think we have some questions in the Q&A windows, right?
Yes, دكتور السلام عليكم.
وعليكم السلام ورحمة الله وبركاته.
معك دكتور أحمد البيلي, Professor Ahmed Al-Bailey with you now. I see that Dr. Abdul Halim Zekri is asking few questions. So if you please, Dr. Halim, can you give your questions to Professor Kanaya?
Yes, okay. Just a moment, we will try to let Professor Abdul Halim ask his questions by himself.
Okay, can I ask a few questions first, please?
Okay, please.
Please.
Sometimes some people use the frequency of 400 something instead of the 900. What about these frequencies? Did you try this out?
Okay, the low frequency region has a quite long distance. However,
Yes.
that one is, yes, the regulations in each country. In our country, in Japan, the 900 megahertz has a quite high input power, like 25 milliwatt. So we can choose. I will choose this 900 megahertz.
So you didn't try the 400?
So yes, 3 years ago, I will choose 400 megahertz, but the antenna size is twice as large as the 900 megahertz. Now that we can focus on 900 megahertz.
Okay. Did you use this design for TX or RX or both?
Antenna case is antenna.
Yes, you're right.
Yes, as
Because
you know that. Okay.
I noticed that you are using ESP32 for your laptop. Is this for receiving?
Okay. So there are two. Okay. Strictly, there are two antennas. One is 900 megahertz. Another is 2.4 gigahertz antenna. The other one is for the connections between the PC and Bluetooth unit. In my presentation, I focused on 900 megahertz. As you know, the antenna is a passive element. Therefore, the TX and RX is the same configuration.
Okay. Dr. Abdul Halim, are you there? Are you here?
Okay, in this case, I can, Dr. Ahmed, will you let him? Okay. Just a moment. We will let him ask by himself.
Okay, that's nice.
Thank you very much for your help and support.
Okay. Actually, Professor Abdul Halim Zikri asks many questions. The first question, what is the overall efficiency of your practical system, Professor Kanaya?
Practical system,
Yes.
which part?
What is the overall efficiency of your practical system? The overall efficiency.
Okay.
Yes.
So So I will focus on the output voltage. So generally, the most researchers focused on the output power. So there are two types. One is power efficiency and another is voltage, output voltage. So if the voltage is increasing, the output power efficiency will be decreasing. So maybe that one is about more than 30 or less, the power. However, the voltage is quite high compared with other researchers. It's okay?
Okay, thank you. The second question, what is the effect of such radio frequency waves on the body and the medical applications, and how the waves are affected by the body?
Okay. So as you know, the
electromagnetic compatibility.
Yes, I know.
Between body and yes, please.
Yes. Okay. So maybe the electric power of the RF regions are quite low. So in my opinion, the effect there are almost no effect compared with the X-ray or something. So another way is if the frequency is a 2.4 gigahertz, like a Wi-Fi or something, and the output power is more than 10 watt or something, the body will be damaged. But in our low frequency regions, in opinion, the bodies cannot make damage.
Oh, okay, thank you. The last question, Professor Abdul Halim Zikri asks about the sources of the harvested RF energy. What are the nature of these sources?
Yes. Okay, I will show another slide. So now in the measurement, we can choose the signal generator. And that one is commercially used one. And in my future plan, we can obtain the ambient energy. Here is receiving power of the RF signal in Tokyo, Japan. For example, in the subway and 100 megahertz, the receiving power is 2 dBm. On the other hand, my energy harvester can work less than 20 dBm. 20 dBm is like this here. So in our design, our systems can work, for example, inside the subway or near the station in the big city or something. This is my future plan for and also the source from the ambient. This is my answer.
Okay, thank you, Professor Kanaya. Any other question, please? Professor Koji, would you like to add something?
Actually, the participants is raising hand, 2 people. I think it's better to take questions from the audiences. Can we take the question from the audiences?
Please, Professor Muhammad Abbas.
Hello?
Yeah, that's good.
Hello.
Hello, Dr. Adel.
Please.
Yeah. Alaikum salam. Dr. Kanaya, thank you so much for your interesting presentation.
Welcome.
I just have a question about whether the harvested energy from the RF sources is enough for the critical applications, critical medical applications like the pacemakers or the cochlear or the endoscopic, or it's better to integrate multi-sources for energy harvesting, like from the movement or the light with the RF to be enough for such application?
So yes, that one's depend on the source. So in the hospital, the regulation for the RF signals is quite limited to other areas. So I think we can use only for example, this electric scope like this, scalpel like this. This one has, but this one, the frequency is quite low, and also the other one is only in the operation. So I think it's difficult to applying the energy harvesting system inside the body by using the ambient energy. On the other hand, WPT, wireless power transfer systems, are already commercially available, like the pacemaker, or this type of other implants. But
okay,
all of this, yes, but all of the implants are only in the quite near to the body surface, and it's not established inside the body. Only for the surface, near the surface here.
I see. So you mean that it depends on the area and the application itself, whether it could be enough or not?
Yes.
Okay, I understand. Thank you so much. Thanks, Dr. Adel.
Okay, you are welcome. And thank you too much, Professor Kanai, for this interesting and important presentation. Thank you.
Thank you very much. Thank you.
Thank you very much.
Well, goodbye.
Thank you, Professor Kanaya, for your time. Thank you for the chair sessions. Now we are going to session 2. The chairs are Professor Salah Abaya, Professor Said Al-Rabi'i. So Professor Abaya from Zuwail City, Professor Said Al-Rabi'i from Manufia University, and Professor Wahid Zahra from EJUST. We would like to welcome the keynote speaker too, Professor Ahmed Al-Wakil. لا لسه هنحطه في استنى عليه بس. بس هو مش موجود. دخل. سوري دكتور انا اتفضل. دكتور احمد الوكيل.
Hello. Professor Salah, can you hear me? I am Mohammed Abu Zahid.
أهلا دكتور محمد زاهد.
أهلا بحضرتك. You are the chair of the session with Professor Said Al-Rabi'i, but he is not yet joined. And there is a co-chair from EJUST, Professor Wahid Zahra. And please start, and you are the leader of the session.
Okay, is Dr. Ahmed?
Please, Dr. Ahmed Wakil, are you here? Dr. Wakil. طب ابعت له على الشات. ابعت كومنت for all. دكتور احمد الوكيل مين؟ بصراحة we are just looking for the Professor Ahmed Al-Wakil.
No problem. Okay, I can.
Dr. Saraf is phoning him now.
Dear respected professors and attendee, it seems that we have some connection problems with Professor Ahmed Al-Wakil. He is not available now, so we are going to drop his session, and we're trying to connect him if he's available. We will try to schedule his talk. Now we will start with second session 3 at 12 on its time in the program. It will be at 12 exact with Professor Magdi Saib. Thank you for understanding. Assalamu alaikum, Dr. Nabil, can you hear us? Professor Nabil? Professor Nabil Ismail?
الو السلام عليكم.
عليكم السلام ورحمة الله وبركاته.
دكتور نبيل اسماعيل.
اهلا، فرصه سعيده يا فندم، شكرا جزيلا.
اهلا بيك. اهلا وسهلا.
احنا قدامنا بالظبط ان شاء الله 5 minutes to start.
ان شاء الله. ان شاء الله.
I can see Professor Magdi Saib is ready. Okay, but we start at 12, exactly 12. Okay.
ان شاء الله.
Hello.
Hello.
Engineering Department, ECCE School, EJUST. I am pleased to be with you for this session, number 3. The chairs of the session are Professor Nabil Ismail from Menofia University and Professor Osama Sayed from Asyut University. Our keynote speaker is Professor Magdi Saib. Professor Magdi Saib he will talk to us about how to thwart rubber hose attacks. I will give you a brief introduction of Professor Magdi Saib. He received his Bachelor of Science in Electrical Engineering from Cairo University in 1974, and he received his Master of Science and PhD degrees in Electrical and Computer Engineering from University of California, Irvine in 1981 and 1985, respectively. He was the Kaiser Aerospace and Electronics, Irvine, California, and the Atomic Energy Establishment at Anshas, Egypt. He is an emeritus professor, and he was the former head of the Department of Computer Engineering at Arab Academy of Science and Technology and Maritime Transport in Alexandria, Egypt. He was on leave working as a principal researcher in the Malaysian Institute of Microelectronic Systems. Now he is the CTO of Great Wall Information Security, Kuala Lumpur, Malaysia. His current research interests include cryptography, FPGA implementations of cryptography and steganography, data security techniques, encryption processors, mobile agent security. He holds 5 intellectual property patents in the area of cryptography. He published more than 70 technical peer-reviewed papers in the information security area. Now I leave the floor for our speaker, Professor Magdi Saib, and thereafter, I hope that Professor Nabil will take over.
Thank you. Thank you, Dr. Amin. It has been some time since I had the honor to meet with you again. Okay, we're going to start this presentation by trying to see what it means actually, rubber hose attack. Okay, let me try to share the. Okay. Can you see it now? Can you see the presentation?
Yes, please continue. Please continue.
Okay. Okay, so the presentation is available to everybody now.
Yes, doctor, we can see it.
Okay. So I will start by trying to shed some light on the title of the presentation, rubber hose attacks. What is it? The whole, it's a short story. The whole thing started in the 1990s with an international competition between researchers in cryptography and developing cryptographic algorithms. All of these algorithms were actually descendant of the Enigma machine developed by Nazi Germany in World War II. And here, because it was an electromechanical machine, the algorithm is always fixed, and the only variable is the key. And that was the case in the 1990 competition. But we have computers now, and computers can be reprogrammed. So I was in the right time, the right area. So I developed actually what's called polymorphic encryption and metamorphic encryption. The difference is polymorphic and metamorphic are key-dependent encryption. In the old algorithms, the algorithm is fixed. The only variable is the key. The key here is used as a source of data operand, but the algorithm is fixed. It's independent. It's like the only secret is the key. But the polymorphic and the metamorphic are key-dependent encryption algorithms. That means every time you change the key, either the process itself change, like in the polymorphic, and the parameters of the process changes also, like in the polymorphic encryption, or in the metamorphic encryption, the whole operations of the algorithm change. So I believe that it's very difficult to attack, and that's the reason that people start thinking of other way to attack algorithms, which is different from classical attacks like well-known differential attacks and so on. The reason is if you have, say, 192-bit.
Professor Magdi, please note that the slides, we cannot see the slides. We are still in the first one.
Oh, okay. I will go and move. Okay. So this is the title.
Yeah, we can see it.
Okay. Now here the story start is like if you want to do any cryptographic security algorithm, you're going to have to use some kind of key. Cryptographic algorithms do three things for you: confidentiality, which is actually hiding the meaning of the data by scrambling it. Authenticity is to make sure that you are communicating with the right person. And integrity, that you make sure that there are no changes done during the transition of the data from the sender to the receiver. So all of these three types of security are based on having a key. So let us assume that Alice and Bob are communicating with each other, but here we have the grandmother wants to know what's in the letters between the love letters between Alice and Bob. So she go to the old-fashioned way. The old-fashioned way is trying to force the key from one of the key holders, because actually attacking polymorphic or metamorphic encryption is very difficult, much more difficult than other algorithms. So they will say that we can just go and physically attack the key holder and try to, by some sort of tormenting or torture, get the key. And the term itself was coined by Julian Assange, and with him was Sulet, Dreyfus, and Ralph Weinman. They coined the name rubber hose attacks. Rubber hose means you actually kidnap the key holder and you beat him till he spell out the key. And Bruce Schneier, which is the guru of cryptography, used it in a lot of presentations and so on. So at that time, I was telling myself, this actually will defeat cryptography. If you're going to kidnap the key holder and get the key by force, by some kind of tormenting it, the person, then cryptography will fail. So I told myself how we can really overcome this difficulty. The presentation is all about that, how to overcome physical attacks to acquire the key from the key holder. So it's actually, the term recognizes that the human factor is the weakest link in any kind of security system. And when we go and we consult companies for their security, we find that always the process, not the algorithm or the security algorithm, is responsible for the defeat of cryptography. It's the process, and the process is integrated with the human activity. So usually it is the human, the weakest link. And because humans are susceptible to all forms of coercion attacks, you can really threaten them, you can physically attack them, you can kidnap them, you can bribe them. So here we're going to concentrate on coercion attacks or physical attacks and how to defeat it by using this technique. It's about really tormenting the key holder. So we need to conceal the concealment of the key to have a secure system. But like I said before, in many instances, it's the human is the weakest link. And in the old times, we used to say we're going to have crypto analysis, but crypto analysis actually can work in some cases, take a lot of time and effort and money to attack a cipher. And especially now with the key-dependent encryption, polymorphic and metamorphic, this will take some time, long time, and a lot of expenses. So from an economical point of view, if you can kidnap the key holder and force him to spell out the key, this is will cut down the time and the cost of attacking a cipher. We're going to show that not only you can protect the security of the real message by using a kind of decoy message. It's like you're forcing the attacker to attack a decoy message, not the real message. But the real message has a different key, and this way we can protect the real message. We only if the guy, the big guy, is going to use torture, you give him some kind of decoy message, but you don't give him the real message. And the idea is we're going to use the cipher itself as a dictionary to which is actually conceal the true secret message. And that means we have two set of keys. One is the original key, which is the key for the decoy message. And if somebody is going to torture me, I will give him this key eventually. But that's not the exact key that is hiding the true secret messages. I'm saying messages because you can have different messages hidden this way. And let us go and see how it is done. First, I have to say that I have developed the chameleon polymorphic cipher 192-bit. Now we have a version 512-bit. And this is a key-dependent encryption. Every time the user changes the key, the algorithm changes. That means, in theory, you have 2 to the power 192 different algorithms. And let us see what will happen. Okay, the sender will do this. He will choose a large cover message. We call it MC. And he will encrypt MC using secure encryption algorithms such as the chameleon polymorphic and the key KC to obtain the cipher CC. So this is very standard thing, except that it is polymorphic encryption, which is very difficult to attack. And then you can send the CC, which is the cipher now. And you can use send the key for the, actually CC is a decoy message. And then you use the KC, send the KC in a secure channel and hide secret message MS1 using what we call JAC-ECC-like encryption, which is, I will explain it now. It looks difficult, but the concept is very easy. And hide in this case is using the cipher CC as a lexicon or a dictionary to transmit the real secret message. And you can actually use this cipher, if it is large enough, you can use it to transmit more than one secret message. Every time you use different key, like we have a set of keys now, KS1, KS2, and you get MS1 and MS2. And the set of numbers, which is KS1 and KS2, are actually the location of the ASCII code of the true secret message. I will explain it, don't worry guys. And this is how to transmit the secret message. What will happen to the receiver? The receiver now can suffer from a rubber hose attack. They will start torturing him. They know he has the key KC. He has to take some torture, otherwise they wouldn't believe him if he surrendered the key right away. But if he surrendered the key KC, they will be able to decrypt the CC. And but like I said before, this is a decoy message. the decoy message that was retrieved by the attacker or the opponent is just not a true message. It has to have some kind of information in it, otherwise they will start doubting that it is not the true message. You have to give them something, but it's a decoy message. Now, if they receive KS1, which is another key different from KC on a secure channel, then they can retrieve MS1, which is the true secret message, not the one that was surrendered to the attacker. It's very similar to what was happening in World War II, that people will make decoy airplanes or decoy tanks to make the attacker attack these wooden or sometimes balloon tanks or balloon artillery or balloon airplanes. It's a decoy. So we're having the same technique here in security algorithms. So we have what we call cover encrypted message, MC. That's the decoy message. And here we have an attack. The guy now has a copy of the cipher of this MC. He wants to get the key. So this big guy will start harming or torturing or mentally tormenting the key holder, and he will get the key. He will get the key to the decoy message, KC. This key. Let me show you. Okay. This key is just a key to a decoy message, which is this one. Okay. Now, this is the cover message or the decoy. He got it. He's happy he got some information. It has to be some correct information, not all junk information. Otherwise, he will doubt it. Then, if we go to the second part, okay, he got the cover message. Now we have another thing. Is like okay, we have another key. We call it KS1, which is a true key to the true secret message number 1, and he get the key, and the receiver will get securely the true message. And if we send another key, we get another message, and if we send the third key, we get another message. So actually, the decoy served two purposes. First one, it tricked the attacker that he got something, which is basically rubbish, junk. But the true and the key that was surrendered to him is a key to a junk message. But the set of keys here can have a set of messages. And let us see what will happen now. So the summary is, at the sender end, we encrypt MC and we get CC using the KC. So and we transmit CC, and then we actually transmit. We have another way. Is like this part. We have KS1, which is the true key, from which is actually a pointer to the locations of the ASCII key representing the secret message, and we can transmit KS1, and we have to have another secure channel to do that. And the receiver, he have KC. Now he can get, if he use KS1 and use the cipher itself, CS1, he can get the true message MS1. He will surrender KC so that the attacker will be happy with having decrypted MC. Okay, how this JAC-ECC has roots in steganography, but it is not really steganography. It's just using the cipher as a new dictionary, and we send actually the location of each character of the true secret message, from which we can get the secret message itself. And we call it, these locations are the addresses of the encountered octet. The octet is not actually, it's not a byte, it's an octet, because you start from a random location and you try to find 8 bits that represent a certain character, ASCII character. And then you record the location of this octet. And when you record these locations, you have actually like a file that which is basically the key to the true secret message. And you can repeat steps 1 to 3 to get all other characters. And this is will be considered as KS1, which is the true key for the true secure message. The address can be 16-bit for message size of about 6. If it depends, you can address 2 to the power 16 locations. So you end up with 65,000 bits. But if you increase the address to 32 bits, you can have a very big message. Okay, and I will stop here and ask you if you still have questions, because I will go to the second part. Any questions? Any questions from the audience?
Yes, I have a question.
Yes.
It seems to me that the approach is similar to privacy preserving biometrics. We use the cancelable approach. We generate so many templates of the original, and the hacker can have the auxiliary templates rather than the original one. Is that correct?
Yes, you're very near the border. It has roots in steganography, and we use the cipher as a medium for hiding, for translating the messages. And when we did testing, we found that each character have thousands of locations. For a relatively small message of 65,000 bits, you will have thousands of locations for each character. Have I answered the question or not yet?
Yes. The other question: have you tried elliptic curve or hyperelliptic curve as a cryptographic approach?
Okay. This is actually asymmetric encryption, what you're talking about. But,
yes.
The encryption we use is symmetric encryption. Asymmetric encryption has advantages in a lot of things, but when it comes to speed and when it comes to security, I vote for symmetric encryption with the hidden key.
Thank you very much. Thank you.
Thank you, sir. Thank you, sir. Okay, any more questions? If no questions, we can progress, we can proceed. Okay.
Yes, please proceed, Professor Magdi.
Okay. This is a summary, graphic summary of what we have. We have a decoy message and we have a false key. And you encrypt with this false key and you get an encrypted message. And now we have an attack, rubber hose attack. The key holder is being tortured or tormented. Torturing is physical, tormenting could be mental. Sometimes if I can get the key from somebody by tormenting him, but not by torturing him. For example, by invading his privacy, by challenging his private things, or by challenging his family or something like that. That all consider rubber hose attacks. So I get the key. He will surrender the false key. And the false key will be used to decrypt the decoy message. Nothing is lost now. Okay, let me just move this one. And he get the decoy message. But there is another key on a different secure channels being transmitted. This one is the address of the different ASCII characters. The certain number of addresses for different ASCII, and from which we can get the real secret message number one. And we have created two communication channels, the green one and the red one. The green one is meant to be decoy, to frustrate the attacker by attacking a decoy message, which is channel number one. But the real secure channel is channel number two, the red one. And here is the summary of the. Suppose that you encrypted some kind of file. We like to encrypt multimedia files because it gives you a lot of variation of different octets. So you have 0 and 1 file, and when you transmit, say I want to transmit the word hello. This way, a second, let me move the. Okay, so now I will record the location of the character H. Let me see if I can move this one. Okay, here. If I here, this is H. The ASCII code is 01001000. So I will search. I will start searching this cipher text from a random location every time. And I will get this octet, which is 01001000. So this is actually, and I will record where is it. And the location is, if you count the number of bits, okay, you're going to transmit first the starting location, which is in this case, this the arrow, this point to the starting location. And then you count how many bits you're going to use. So the starting location is 854, and you're going to count 26 bits. So if you look at this, the arrow is pointing to the location of KS1, which is 854, starting from the first bit in the file, and you have 26 bits to count. So if we count this one, we get what? We get the location of capital H. So we record this location. Okay, in this case, I will say it's location 10. And then you repeat the same thing for the character E and L and L and O. So you end up with these numbers, 10, 18, 15, 15, 11, and so on. And these are the keys for the location. The cover message can be transmitted only once, but it can be used many times. If it is large enough, you can use it many times by having different keys. And don't worry about surrendering, like I said, KC. And if they decrypt and get the original message, it's just a trick message, decoy message. And we prefer to have a multimedia message encrypted because it gives you a lot of variation of different octets. And we tested the method. We found that for 65,000 K bits, we will find that each character in the alphabet can can be found in thousands of locations, between 6,000 to 10,000 locations for each character. So frequency attack will not succeed in this case. And we have something else about word of caution. You have to give something to the attacker, otherwise he will doubt that it is a true message. For example, if you're going to hide a lot of information, give some information in the decoy message, so at least they know that this is a true, not a decoy or a false message. And
Professor Magdi, please note that
yes.
You have only 10 minutes remaining.
Okay,
and then 5 minutes for discussion.
Okay, I will. Okay. There is another use for this methodology beside securing messages. You can secure your cryptocurrency wallet. If you know that some people in California, for example, can have cryptocurrency wallet with $100,000. So if they get the key, they will acquire the $100,000 from your cryptocurrency. So we advise you to use some method like this, because if they kidnap you and they start torturing you to get the key for your cryptocurrency wallet, you will lose up to $100,000. This is a summary of the message. We have N messages from M1 to Mn, and let me fix this. Okay, each message has different key. That's okay. First, remember the decoy message, the one in yellow here on the upper side, left, right hand side. This is the one that you're going to surrender eventually if you're being tortured. But K1, K2, and K3, and up to Kn are the true keys for the. So if you have K1, and okay, you surrender, you send the K1 to the receiver, then the receiver will be able to get M1. And same thing. The method is based on using a very strong cipher, the chameleon cipher, which is a polymorphic cipher, which is key-dependent encryption. And when Rami, Dr. Rami in your university was my graduate student, we developed an implementation, a microarchitecture implementation. And I remember he and his colleague Ahmed Saif were able to encrypt video signal in real time. So the microarchitecture is still there. I think it's with Rami, and it can be used to encrypt a lot of things. You don't forget that if you're going to use cryptocurrency in the future, the most valuable thing is your key. Now I'm opening the platform for questions. I hope they are easy questions.
Thank you, Professor Magdi, for this
nice
presentation. And I think it is quite clear, even for non-specialists, at least the framework. So I leave the floor to Professor Nabil from Menofea University to ask or to open the floor for the audience for any questions. Thank you.
Thank you very much. Thank you. Professor Magdi, I want to ask you about the length of the keys. How many bits?
The original key, the one that will be surrendered, is 192 bit if you use chameleon polymorphic. But the key length for the true secret messages, it depends on the size of the messages. Actually, they say that's a real problem here. It's if you're going to have a long message, then it will be a long key because it's a location of all the ASCII code. So, but I believe it is secure message. You actually the penalty or the cost is the key length, because but it's like you're protecting a lot of things here. So you're going to have some kind of payment to do here.
What other performance criteria we can use to judge the system?
For what? For
performance, performance criteria as a whole.
Okay, if we're talking about the decoy message, it is all published about polymorphic encryption. The performance is as good as AAS, or sometimes it's better even. And it is published. One person can download the performance criteria. But if you're talking about sending, the secret messages are not going to be like a big table or something like that. It's supposed to be very short secret messages for very secure intentions. If you're going to, it's like, okay, for example, the war is tomorrow. This is a highly secure message. You don't want the war is tomorrow to be handled by an attacker. But you're not going to send a picture of my picture encrypted this method, because it is, of course, you have to do some kind of encryption using symmetric standard or polymorphic or metamorphic encryption.
Thank you very much.
Okay, there is a cost for security. Yeah.
Okay.
There is a cost for security. If high security, high cost. Yes. Any more questions? Thank you for the question. It is valid question.
Thank you very much.
Thank you, sir.
Professor Magdi Saib, we have another question from Professor Osama Said. Okay. I will give him the floor to talk, to ask you his question. Professor Osama Said, you can ask your question now. Okay, I can share his question if he's not available. He's asking, what is the performance of this method in case of the attack make a changes the surrender key? The question is I can repeat the question again. What is the performance of this method in case of the attack make a changes the surrender key?
Okay. If we give the attacker the false key for the decoy message, the story ends here. He doesn't know that we have other keys using the cipher as a lexicon. If you put some information, valid information, inside the original message, the decoy one, you can trick the attacker. But of course, when you go and you're going to have multiple messages using the cipher as a lexicon, it has to be short messages, not long messages. And performance here is a little bit sacrificed for security. It's like in the old times, we used to worry about memory. We used about file transmission size. We used to worry about, you remember that I can give you a flash memory that can hold keys for a huge number of files. And it's like the idea of performance here is now it's different. Security is more important than like few milliseconds more or less.
Okay, thank you, Professor Magdi, for answering the question. If there is other questions? Okay, I can. Okay, there is another question. What are factors effects on the length of surrender key? What are factors affect on the length of surrender key?
Okay, if you're going to use chameleon polymorphic, the key size is fixed 192 bit, but we have a version 512 bit. And the performance, even with 512 bits or 192 bits, it is much better in some cases, because we implemented using FPGA, not only software but hardware, and it's much better than most standard algorithms in the 1990 competition and it has some advantages in security compared to AES. AES is already cracked. 128-bit is already attacked successfully, and there are also big rumors that the 256-bit is already attacked. So that for the first part, the decoy message. But if we're talking about the second one, it's like, okay, the second one is about sending a series of small messages, very highly secured small messages. Here, the performance is of secondary importance. Here, security is number one. Of course, okay, there is always a price. Security is against convenience. If I have a bodyguard standing in front of the gate, checking everybody, that's not very convenient, but this is a price we have to pay, a cost we have to pay. Also, if you want to have high security, you're going to transmit larger keys. And people don't doubt larger keys now. It's like I was testing this. When they see transmitting larger keys, they don't think it's a key. They think it's a kind of another file. It's I am from because security means money, and also lives, money and life and human life. So performance is a few milliseconds plus or few milliseconds down. It's academic, but in real life, it's different. I'm talking about a guy who's carrying $100,000 in his pocket in cryptocurrency. He's not worrying about performance. He's worrying about losing $100,000. That's my answer. I think people can debate this, of course.
Thank you very much, Professor Magdi. Thank you.
Thank you. Thank you, sir.
Thank you, Professor Magdi. Thank you, Professor Nabil, for sharing this session. And also, I would like to thank Professor Osama. He joined us lately. He's one of the sharers of this session, and he asked some questions at the end. So we reached the end of this session, session 3. We would like to thank Professor Magdi Saib for one more time. Now we're going for a break after this very long start day. So we have a break till 1:30. Then we return to the technical session. We have 2 technical sessions at 1:30, technical session 1 and 2. It will be in virtual room 1, this room, and the technical session 2 will be in virtual room 2. I hope that the chairs can join us at 1:20 for setup, and the authors also, if it will be helpful if they join 10 minutes later for setup and make everything clear. Thank you, everyone. See you at 1:30.
Thank you, sir.
Thank you. Thank you.